This assessment asks us to predict the product for this electrocyclization reaction. Our starting material here has 6 pi electrons. It's got 3 pi bonds that are all conjugated to each other. Each pi bond has 2 electrons. That makes 6 pi electrons. And we are under thermal conditions with heat. So that means it is a disrotatory process. Our mechanism will have this pi bond attacking this carbon. That will shift these pi electrons over each. And so this will be the mechanism for this reaction. It is a disrotatory process, which means the 2 carbons, these 2 N carbons will rotate opposite directions from each other. So one will rotate in a clockwise direction, and one will rotate in a counterclockwise direction. That means our product will be a cyclohexane, a 6-carbon ring with our 2 pi bonds in the middle. And when this side rotates in the clockwise direction, that takes this methyl group and it rotates it up. So we'll have 1 methyl group on a wedge. And when this other carbon rotates in the counterclockwise direction, it rotates this methyl group down. And so our other methyl group will be on a dash. The 2 carbons could have rotated the opposite direction, and so we will get the enantiomer of this product. This is a racemic product, depending on which way the 2 carbons rotate in a disrotatory fashion. But this product will be the product of this 6 pi electrocyclization under thermal conditions.